In this video, we will see code implementation. Now let's quickly check out how we can solve this question. So basically the code implementation of majority element. So let's check out the first brute force approach. So we discussed the approach one, brute force. Okay. So basically what you need to do. So let me create something. So suppose we have an array same with 2, 2, 1, 1, 1 and what will be the n here? N will be 7. So this is the given data. So what I will do, I will basically start with one loop, right? Or basically I will iterate all the elements. So I will start from 0 to n, right? So again, this is a pseudo code, okay, not the actual implementation of the code. But you can understand in any language. So basically, they will start from 0 to n, and I will check if my ARR of I is equals to ARR of j. So basically, if both the elements are equal, what I will do, I will update the count. Okay. So you need to initialize the count basically. So for each element, I will initialize the count with 0. And yes, so here you can see both the elements are equal. I will update the count. You can start with 0 or you can start with 1. Okay. So that is up to you. But again, the time complexity will going to be same. And so see here. You can start with I plus 1, that too, that is also, but right, again, right, you can tweak this code. Basically, suppose you have equal elements, so you can write something. So if the element is already counted, so don't need to count it, something like this, right? And after this jth loop, basically you will check if your count is uh, if your count is greater than the n by 2, what I will say that this will be going to be my majority element. Basic print majority element. Okay, or whatever the majority element is. So suppose majority element here will be the array I. So this will be our brute force approach. Time complexity, again the time complexity will be here, that will be big O of n square. Now let's talk about the next approach that we have discussed, approach 2, with using hash map, right? So it was using objects or hash maps. Now here, first I will store all the elements. So basically I will create one object. So let's suppose object equals to one this object, empty object, and I will simply start iterating through my object. So basically I will say let x of nums, basically all the numbers. I will check if that element is present in my object, or if it is not present, if it is equals to undefined. Okay, what I will say, I will simply define it. How I will define it? Simply I will define it with 1, right? If it is already defined, right, the else condition, if it is already defined, I will basically update the count as object of x plus plus. So this is how I have created the hash table, right? So this is the creation of hash table. Now what I will do, I will simply now count the frequency, basically max. I will check the max. So I will take one max with starting with 0, and my majority element, suppose mj, majority element, that is also I am initializing with 0, or you can take the first element as your majority element. Okay, and what I will do, I will simply iterate in the object. So for that key in object, if you can remember, or yes, let's suppose let x in object, so I will check if object of x, right, is greater than max. Basically update my max, so max will be object of x, and the element will be my majority element, so my mj equals to x. Okay, and yeah, that's it. Just from here you will get a max and you will get a majority element, right? And the problem was saying that there will surely be one of the majority elements. So what you can do, you can simply return your mj, right? Just check your mj here will be commit out to be string, so you need to convert this to be a number. All right. So this will be our number. This was the second approach. Now the next approach, that was Moore's voting algorithm. Approach 3. Yeah, approach 3, that will be Moore's voting algorithm. So here basically what we need to do, I will first assume that this my majority element will be the first element, right? So 0th element. I will assume this. Okay, and I will initialize the count with 0, and then what I will do, I will simply iterate in the loop. So again, I will be from 0 to n, total number of all the elements. And if I will basically, if my count is equals to 0, what I will do, I will update the count, right? So what I will do, if my count is 0, again I will, so we'll talk about this condition later, right? So that it will make a sense. Suppose if I am getting my ARR of AI is equals to my majority, right? That I decided that this will be my majority. So what I will do, as we checked, we update the count plus plus, and if it is not, right, the else condition, if it is not, what I will do, I will decrease the count, right? This we already checked it. So if the element is equals to my MJ, I will update the count. If it is not, I will decrease the count. Okay. But whenever my count is 0, then I again need to restart it, right? So if my count is getting 0 anytime, what I will do, I will again assign a new majority element. That will be my ERR of I at that time. So this will be my new majority element. And again, it will start with 0, 1. And yeah, so here you can see that's why I have initialized with 0. So first my majority element will always be the 0th element. Okay. And yes, in the last, what I will do, I will return this. So I'm using return. I am assuming that this will be going to be a function. It's totally your call. You can print as well. All right. So again, that's a pseudo code. Right? That's not an actual code. But yes, if you are good in coding, you know the coding aspect. So basically, you can write the code in complete DSA. So yeah, this will be your Morse voting algorithm. Here you can see the time complexity is big of n only, right? So in the next video, what we will do, we will try to discuss how this works. So we will do a small amount of a dry run of this Morse voting algorithm. I hope this dry run, there is no need of these using objects and hash maps dry run, but we will do a dry run of majority element. Okay. So see you in the next video.